In Chapter 12, we're going to be looking at probability and look at how to interpret probability and describe the likelihood of an event happening, and then go on to be able to work out the probability of an event happening. There are a couple of little multiplication squares. You might like to have a go at these and send me your answers. Now, my first question to you is, how many words can you find relating to probability? If you find between 1 and 4, you've done good, that's good. Between 5 and 8, ace. Between 9 and 12, that's awesome. And if you manage to think of 13 or more words relating to probability, then that is absolutely amazing. You're a superstar. So pause the video now and see how many words you can find. So how many of these words did you get? Copy out the probability scale from 0 to 1 as on this slide, and then see if you can match the green labels with the words and the orange labels below the scale with the percentage chance of these events happening. Pause the slide while you are doing this and then check your answers in a minute. Now, here are the solutions. How many of them did you get right? Now, probability is always lies, the probability of an event happening always lies between 0 and 1. If you have the probability of an event happening is equal to 0, it means it is impossible. And if you end up with a probability of an event happening being equal to 1, then it is a certainty. It will happen for sure. All probabilities should, some people have been writing them as percentages as on this slide here, but generally speaking you would write your probability as a decimal as on the scale here, or as a fraction in its simplest form. We don't generally write a percentage to describe a probability, and we don't normally say an even chance when describing a probability in maths. Always give your answer as a decimal or as a fraction in its simplified form. On this slide we have a probability scale going from 0 to 1. And we've got some examples of events here happening. So we've got event A, the probability of getting a heads on a flip of a coin. B, the probability of scoring 101% on a test. C, going to sleep tonight. D, the probability of winning the UK lottery. E, the probability of being left-handed. And F, the probability a BWS student walks to school. Now just think about those. I mean, you all may end up with slightly different answers, but I would like you to put arrows, labelled arrows, on the probability scale to show where you think the probabilities would lie. So let's look at event A, the probability of getting heads on the flip of a coin. Pause the video and place an arrow where you think A will lie. Well, I've put my arrow with A at 0.5 because when you flip a coin you get either a head or a tail. So the probability of it landing on a head is going to be 1/2, 0.5. Looking at B, the probability of scoring 101% on a test. Pause the video and draw an arrow where you think that will go. It's impossible to get more than 100% on a test, so the probability of getting 101% is going to be equal to 0. Now looking at C, the probability of going to sleep tonight. Pause the video and put an arrow for where you think C will be on the probability scale. Well, it's almost certain you're going to go to sleep tonight. One or two of you, I suppose it's not absolutely certain, one or two of you might decide you want to stay up all night, but if it's not at 1, it's going to be very, very close to 1. Now the probability D of winning the UK lottery. Well, I put D close to 0. It's not absolutely impossible, but it's very, very unlikely to happen. And the chance of it happening are very, very small. So it's got a very small probability. Now looking at E, the probability of being left-handed. Well, think about this. You can either be left-handed or right-handed. Now, roughly 10% of the population are left-handed, so E would be closer to 0. Okay. And the probability that a BWS student walks to school was a lot of students tend to walk to school. Some get buses, some get trains, so I would probably put that somewhere up there. But without all the data at hand, this is just I can't give an exact solution, but it's probably up there somewhere. On this slide, we've got some words below here to describe the probability, the likelihood of these events from 1 to 10 happening. I would like you to just think about them. So the probability you will celebrate your 10th birthday tomorrow, well, that's going to be impossible, isn't it? Because you're all at secondary school and you are all 11 going on 12. So that one will be impossible. The probability that tomorrow you will have a cold. Well, that's one for you to discuss. The probability it will rain tomorrow. Well, that depends. I mean, on this slide I said likely, but looking at the weather we've had recently, it seems quite unlikely. But we could always check the weather forecast. The probability you will be struck by lightning tomorrow. Now, it is possible to get struck by lightning. The chance of it happening tomorrow are going to be very, very unlikely. So that probability is going to be very, very close to 0. The probability you will have something to drink tomorrow is pretty certain because we all need fluid to live. The probability sometime tomorrow you will watch television. You may not watch television, but it is pretty likely that you will. So that's going to be somewhere between 0.5 and 1. So if you're at school, the next person you pass in the corridor will be male. I've actually put an even chance, but actually they're probably, with it being a boys' school, more males than females. So it's probably more likely that the next person you pass will be a male. The probability that the sun will rise tomorrow, I would say, is certain. The probability of you rolling the number 6 on a dice on one throw is unlikely. It could happen, but it's unlikely. And the probability you will still be alive when you're 100, unfortunately, is unlikely, but as medicine and technology and improves, life expectancy will also improve. So maybe it's not so unlikely. Now, with probability, as you've seen from our discussion so far with these questions, we all have different ideas, and it all depends on what is happening at the time. So, for example, we are at the moment this year going through a very hot spell in May, so the chance of it raining tomorrow I would probably say are unlikely. But if I was to do this same slide in the winter, the chance of it raining tomorrow were probably more likely than now. So it all depends on the circumstances as well. And probability is something that it just makes you think and think of a sensible answer. Now here we've got a statement. It is impossible that Ethan will take a red sweet from... Now which one of these would be impossible? Which one will not happen? Would it be bag 1? Is it impossible to get red from bag 1? No, there's a red one there. And in fact, bag 2, 3 and 5 all have red sweets. The only one that would be impossible for Ethan to take a red sweet from would be bag 4, because they are all green. So your answer should be bag 4. Now we've got to read the question carefully. In the last question it said it is impossible that Ethan. Here it says it is unlikely that Ethan will take a red. So it's not impossible. He could get a red sweet, but it's unlikely because they're probably, you want the bag that has got more green than red. So looking at these, it would be impossible to get a red from bag 4, so that's not our answer. We would definitely get a red one from bag 5, so that's not the right answer. So bags 1, 2 and 3 all have red sweets, so the one that has the least in it is most unlikely to get a red sweet from is bag 1. So reveal the answer, bag 1. So reading the question carefully, it is an even chance that Ethan will take a red sweet from. So 50-50 chance, so that it's the bag with the same number of red as green. So the one with the same number of red and green is going to be bag 2. And there we reveal our answer. Sometimes words aren't enough, and as mathematicians we want to be more accurate when talking about probability, and to be more accurate we want to express probability as a number. So the probability that an event will happen is a number between 0 and 1. The probability for an event which is certain will equal 1. The probability for an event which is impossible will equal 0. And probability can be expressed as a fraction, a decimal, and sometimes as a percentage. But as I've said before, we are going to write our probabilities as fractions or decimals. I would like you to pause this slide and then copy it out please in your exercise books. Remember to write a title, Chapter 12, Probability, and today's date. So if I had a bag containing an apple and a pear, what is the probability I will pick out a pear? So I would write that as P, the probability of picking a pear. So P outside the bracket stands for probability, and inside I put the pear. So the probability of picking a pear equals, well, how many pears are in the bag? There is 1. And how many things in the bag altogether? 2, an apple and a pear. So the probability of picking a pear is 1/2. On this slide we've got set A, a set of shapes which we called set A, and there are 11 shapes altogether. So 11 shapes in total. Now a shape is chosen at random from the set, and we, for part A, want to work out the probability that you choose a triangle. So we write P triangle equals. How many triangles are there? Well, we have 1 triangle out of a total of 11 shapes. So the probability we would write as 1/11. For B, we want the probability of choosing a circle. So P circle. How many circles are there? We've got 1, 2, 3. So the probability of choosing a circle is 3/11. So 3 shapes out of a total of 11, 3/11. C, the probability of choosing a square. we would count how many squares there are. We have 1, 2, 3, 4, 5 squares out of a total of 11 shapes, so 5/11ths. D, the probability of choosing a rectangle. How many rectangles are there? We have 1, 2 rectangles out of 11 shapes altogether. So the probability of picking a rectangle at random would be 2/11ths. E, the probability of choosing a hexagon. How many hexagons are there? Oh, there aren't any. So the probability of choosing a hexagon is impossible. It's 0 out of 11, but you would not leave your answer like that. You would just write it as 0. So you may ask, what is probability? Well, probability is the likelihood or chance of an event happening, and the probability of the outcome is the number of ways an outcome can happen over the total number of possible outcomes. So I'd like you to copy out this slide in your book now. So pause the PowerPoint and copy. A box contains 3 bags of salt and vinegar crisps, 4 bags of cheese and onion crisps, and 2 bags of beef crisps. One of these bags of crisps is taken from the box at random. Work out the probability that the bag of crisps will be A, salt and vinegar, B, cheese and onion, C, beef. Now the first thing you need to do is count up how many bags of crisps there are together. So the total number of bags, well, I've got 3 bags of salt and vinegar, 4 bags of cheese and onion, and 2 bags of beef crisps. So 4, 5, 6, 7, 8, 9. You may like to pause the video now and have a go at answering the 3 questions. Well, the probability of choosing salt and vinegar, well, there are 3 bags of salt and vinegar, so it would be 3 and 9 bags altogether. So the probability is 3/9, but we must always simplify our answer. So divide both numerator and denominator by 3 would give a third. The probability of choosing cheese and onion, well, there are 4 cheese and onions, so I would write probability cheese and onion would equal 4/9. The probability of choosing beef, well, how many beef are there? Well, there are 2 bags of beef and 9 bags altogether, so we would write 2/9. What is the probability of choosing a red counter from this bag? Well, we have 12 altogether, and 1, 2, 3, 4, 5, 6, 7 are red. The probability of choosing a yellow counter, well, there are 12 counters altogether, and 4 of them are yellow, so 4/12, which can be simplified down to 1/3 by dividing both numerator and denominator by 3. The probability of choosing a green counter, well, there are 12 counters altogether, and 1 of them are green, so the probability of choosing a green counter is 1/12. What is the probability of this spinner landing on pink? You may pause the video. So if we look at this circle, it's split up into segments like this, and there are 1, 2, 3, 4, 5, 6 segments, sectors. So we have 6 altogether, and 1 of those is pink. So the probability of it landing on pink will be 1/6. What is the probability of the spinner landing on yellow? Well, again, we can see that our circle is split up into 6 sectors like that, 2 of which are yellow. So 2, 6 are yellow, but we can cancel that down by dividing both numerator and denominator by 2 to give us 1/3. What is the probability of it landing on light blue? Well, we have 3 sectors that are blue, and there are 6 altogether, so 3 6, which is 1/2. Now you must read the question very carefully. It said, what is the probability of this spinner not landing on pink? Well, there are 6 sectors altogether. How many of them are not pink? 5 aren't pink. So the probability of it not being pink is 5/6. What is the probability of choosing the letter at A from the word? Well, the word is mathematics. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters altogether. How many of them are A? We have 1, 2. So the probability of choosing an A at random from the word mathematics is 2/11. What is the probability of choosing a consonant at random from the word? Well, there are still 11 letters in the word, and our consonants are all the other words that aren't vowels. So we have 1, 2, 3, 4, 5, 6, 7. So 7 are consonants. Or you could say we're 4 are vowels, then that means that the rest are consonants. So 7/11. Now here's just a little thing just to think about how confident you feel so far with this topic. Are you A, B or C? And now it's your turn. I would like you to do exercise 12A on page 249. On the slide it says from question 4 onwards, but please follow the instructions as given on Insight. The answers will be on the next slide, but I only use those after you have completed all the questions, shown any working out, and made sure that all your answers are written as a fraction in its simplest form or as a decimal.